Unit 5.2, we do practice. Consider the reaction 2NOCl gas yields 2NO gas plus Cl2 gas. The rate law shows that it is a bimolecular reaction with a rate equal to K times the concentration of NOCl squared. When the initial concentration of NOCl is 0.391 molar, the rate is 9.32 times 10 to the negative third molar per second. So with that information, they want us to find the value for K with units, and they want us to answer the question, what will the rate of reaction be when the concentration of NOCl is 0.634 molar if the reaction takes place at the same temperature? So first, let's tackle the question of finding the value of K with units. So they've given us our rate. So they've told us that our rate is equal to K times the concentration of NOCl squared. And they've given us values for both the rate and the concentration of NOCl. So we're going to plug in 9.32 times 10 to the negative third molar per second for our rate, and we're going to set that equal to K, because that's what we're solving for, times our concentration of NOCl, which is 0.391 squared. So now when we solve for this one step at a time, we'll have 9.32 times 10 to the negative third molar per second equals K times 0.1529 molarity squared. And then we want to divide, in order to isolate K, we need to divide our rate by our new concentration. So we're going to have 9.32 times 10 to the negative third molar per second divided by 0.1529 molar squared. So now we need to clean up our units a little bit before we continue on with our math. So we're going to cancel out our molar on top and one of our molarities on the bottom for our units. And now we're going to be left with molar times seconds, but on the bottom. So when we finally do the math and calculate, we're going to take 9.32 times 10 to the negative third divided by 0.1529, and we get K that's equal to 0.0610. And with our new units, we're going to get our molar to the negative 1 times second to the negative 1. We also could write 1 over molar times seconds. Either one of those units will work. And that's how we solve for the value of K with units for this first part of this question. For part B, they're asking, what will the rate of reaction be when the concentration of NOCl is 0.634 molar if the reaction takes place at the same temperature? So what they're telling us with specifying that the reaction is taking place at the same temperature is they're letting us know that we can use the same K that we just calculated for part A. If the temperature changes, then our K changes, our constant is going to change. But since our temperature is the same, the K that we just calculated we can use because that's going to remain constant for this reaction as well. So now we're just going to plug in the numbers that we have. So it's still our rate equals K times the concentration of NOCl squared, but this time we're solving for rate. So it's going to be rate equals 0.0610, and our molarity to the negative 1 times seconds to the negative 1 times 0.634 molar squared. And that squared means that we're going to be squaring not only the numerical value, the concentration value, but also that molarity units. So before we do any calculations, let's once again clean up those units. So my molarity to the negative 1 is actually going to be canceled out. It's going to cancel out my molarity squared. So I'm just going to be left with 1 molar on my 0.634. So now when we do our math, we get, we're going to take 0.634 and square it, and then multiply that by 0.0610. So our final numerical value is going to be 0.0245. So our rate is going to be equal to 0.0245. And we've got molar times seconds to the -1, so we can rewrite that as molar per second. So our rate for this reaction at the same temperature but a different NaCl concentration is going to be 0.0245 molar per second.